We'll go ahead and get started. So we have time for questions. I imagine there might be some questions at the end of this, especially since I'm subbing for someone. But the good news is the person that I'm subbing for can hear us, especially if you speak into the microphone. So at the end when there's questions, make sure you have a mic before you start shouting out questions. This presentation is called My Life in DevOps. About 2 years ago, Northwestern started the transition from our local infrastructure to an AWS infrastructure. And we've learned a lot along the way, as many people that have gone through that sort of transition have. This is sort of an update on where we're at, what we've changed, what we've learned, and also what our struggles still are. Oops. I have to navigate two computers. But before we start, in case it's not obvious, I am not Michael Klein. It's actually Michael Klein's Life in DevOps. My Life in DevOps was a little bit different. It was largely Michael saying, hey, do you mind if I spin up 5 more instances of this? And me going, wait a second, how much is that going to cost? And him going, don't worry about it, it'll be fine. So this is sort of, I was living vicariously through Michael. But the good news is that we did a lot of this work together. He did a lot of the technical work, and together we did a lot of the planning, so I can speak to a lot of the points. But first, a quick little prologue. So at last Samvera Connect, we gave an update about our initial move, which was our Avalon system into AWS, which by far is our most complicated system. And so, like smart people, we started with our most complicated system. Because that's what you do, right? When we started with that, we took Haiku's CloudFormation templates and reworked them for our use case. So those of you that are familiar with the Haiku CloudFormation templates knew that it was meant to stand up a single infrastructure all at once. But we knew right away that our goal was going to break out multiple heads on top of a common core infrastructure. So the first thing we did is we kind of attacked those templates and peeled off Fedora and Solar and the kind of base infrastructure, and then built out an Avalon head on top of it. And then also, one of the reasons we were moving Avalon to AWS is that transcoding video is hard and takes a lot of gear. When AWS has this great thing called Elastic Transcoder that is remarkably cheap and incredibly fast. So we could throw 10,000 hours of audio edit, which is something we could never do on our local infrastructure. It would take us weeks to transcode that kind of stuff. So then we kicked back, we started drinking mojitos, and we were really proud of ourselves, and we presented at Samvera Connect. But inevitably, little breaks started to happen, right? We started to notice things weren't in all the ways we wanted. First of all, CloudFormation was a unique, to call it unique is interesting, it was a unique template language that frankly our DevOps folks, we couldn't get buy-in from. Like when we were trying, they tried to learn it, they were largely puppet trained. There was a lot of resistance, to be very frank, on learning a new thing. We had to write and maintain 3 different custom lambdas for parts of the infrastructure that AWS themselves didn't maintain. And those custom lambdas, strangely, were for parts of the infrastructure that were AWS specific. So in particular, things like Elastic Transcoder, we had to write custom lambdas to create and delete and manage those things. Change sets themselves, so within a CloudFormation template, you can apply a change set to update your infrastructure. Those were declared separately from the base infrastructure, which is, again, it's just the way it's done, but it was a little tricky to wrap our heads around. So we started doing what one does when they're in a hurry, which is to jump onto the console or jump into the AWS command line and start making manual changes. And every time we did that, we accrued technical debt, we felt really guilty, and we knew we were headed down a bad path. In addition, and I kind of hinted at this, our infrastructure, this shouldn't say got complicated. This infrastructure is complicated, right? It's complicated to stand up, it's complicated to run. And while in our initial move to AWS, we largely tried to replicate what we had in our local infrastructure. So we made use of Elastic Beanstalk. And we might not have backed up enough and looked at it hard enough, but we made an initial run. We had Fedora running in a Java Elastic Beanstalk container. We had Solar running in a multi-container Docker, Elastic Beanstalk, Zookeeper and a multi-container Docker one. Then we had multiple heads running Ruby and Puma. So we had different default deployments. We had different options for every stack. It was a lot to keep in our heads every time we made changes. In a lot of ways, it was not a great scenario. So we backed up a little bit, and this happened, actually it was not that long ago. It was only about 6 months ago, maybe going on 8 now. And we took a hard look at our current infrastructure. We said, we know we want to make a lot of updates. Should we put the time into CloudFormation itself, or should we start looking at new tooling? And we decided to take a hard look at Terraform, and it made a lot of sense for all sorts of reasons. First of all, it had more granular control over AWS resources than we were finding with CloudFormation. Also, we found that it was actively and openly maintained. So CloudFormation, its development cycle seemed like a lot of other AWS stuff, which is randomly you would get a notification that there was some new feature in it, and that was largely if you were paying attention to their blogs, right? So suddenly something would come across, and you'd go, oh, whoa, I should use that. But it was unclear where they were headed or how they were making decisions, whereas Terraform was openly and actively maintained, and they had a roadmap. In addition, there was a lot of community modules, so there was a lot of people we could lean on. And then when we started showing the code and working with our DevOps on it, they seemed to grab onto it really quickly and easily. It was an easy transition from Puppet. And this last one shouldn't be ignored either, is that Terraform is a multiple provider solution. So even though we're baking in a lot of stuff on AWS internals, things like Elastic Transcoder and SQS service, there are analogies in other environments. So this allowed sort of an escape hatch if need be. We could take a lot of our core work and apply it to somewhere else, tweak some things here and there. I already hinted at this a little bit, but we used it as an opportunity to reevaluate, as one should with infrastructure like this. And I'm going to pause too and say that from where I'm standing, one of the interesting things about this move to AWS and move to cloud infrastructure is the ability to do that really quickly and rapidly, which is something we didn't have before. So when we were on bare metal and on VMs, spinning up new VMs for experiments is tricky in an IT environment, right? Especially when you're talking about large infrastructure, where here we could build up whole stacks and play around with them and replicate exactly what we're doing in production and experiment. So again, we kind of double down on using AWS services when possible. Things like our Redis and our database and our queuing service, as well as Elastic Transcoder. For everything else, we decided to use containers for everything else without exception. And that was really sort of the biggest game changer. And besides that, we're still thinking about whether we should get into Elastic Container Service or Kubernetes versus the convenience of Elastic Beanstalk multi-container deployments, which is what we're currently doing. So those are nice because they're sort of a set and forget. We don't really have to think much about them. We point to some Docker containers and it runs it, and we run. So it's a good way to get involved in it early. However, there's a lot of knobs to be turned on these other deployment styles. And then while we were working on this, Amazon released into production Fargate style deployments versus EC2 in their Elastic Container Service. So that's yet another thing to think about. We've started to experiment with that. There are times to use it, I think, times not to use it. We're not quite sure where those are. And then while we were at it, the EKS service came out, and we said, well, should we also be thinking about Kubernetes, right? It seems like a never-ending game, but that said, again, the ability to experiment is one of the great benefits of this. So now I'm going to get into the tricky part, and I might have to read some complicated notes here that Michael's left for me. So deployments then. This 2 steps. This is a great, simple-looking slide, but a lot of stuff happened in these 2 steps, right? So deployments originally in our original AWS infrastructure, a push to GitHub, triggered a GitHub notification that notified the AWS pipeline. And the code pipeline then pulled down the code and packaged up the app and pushed a new version to Elastic Beanstalk. Elastic Beanstalk would then run the entire Rails deploy cycle on every instance that was currently running, right? So that includes a code pull, installing dependencies, things like ffmpeg and bits and vips, a bundle install of everything, and then it precompiled the assets, and this is on every single instance that happens to be running at the time. And then it would go green, health checks would fire off, and then switch over. So that deployment time took between 20 and 30 minutes. So it was, again, it worked fairly flawlessly, but it took a long time. Rollbacks were a little tricky, right? Or trickier than they ended up being. So deployments now, while this looks like a lot more steps, it offers a lot of benefits. So deployments now take less than 5 minutes, and rollbacks are remarkably easy because they're just Docker containers that are tagged. In addition, because it's less than 5 minutes, we can do true zero downtime deployments. And so in our production infrastructure, where we're running at like a course reserves instance, there's never really a good time to take down Avalon. People are using it for classes at 8 o'clock at night. They're using it in the morning because they're late for class and they have to be watching things and working on papers. So again, these less than 5 minute deployments have changed the game. And so what the deployment looks like now is a push to GitHub triggers a Jenkins build of the Docker image, and we're using what's called a multi-stage Docker build, and that's where we're really saving the most time, and I'll get into that on the next slide. After the image is built, it tags it logically, like NUlib, staging, Arch, or whatever application we're working on. It pushes that to Docker Hub, because there's nothing fancy in our Docker images. They're fairly generic. We push them up to Docker Hub, which triggers the Elastic Beanstalk app to restart. So it doesn't do a full deployment. It just restarts the app, and on restart, the Elastic Beanstalk pulls down a new Docker container, stops and restarts it, and then we're done. And all that takes, again, less than 5 minutes, usually around 3 minutes. There's a lot packed into that slide. And this is the big one. I'm going to take a drink of coffee real quick.
Sure, that's coffee.
Mm-hmm. All right. So this next little bit here is about where we're saving time on deployments. So I'm going to talk a little bit about some Docker principles and then how Docker builds work. I know some people already know this stuff, but some don't, so bear with me a little bit. So one of the key Docker principles is that layers, so this sort of represents a Docker build, and each layer acts as a delta. So in a single stage build, every step produces a layer that becomes part of the final image. And so build time dependencies and other temporary files are included, right? So each of those deltas, every time, even when you don't need them, they kind of come along for the ride. In a multi-stage build, which is what we're doing here and what we've converted to, we separate build and runtime dependencies and leave all of that behind, and only, which ensures that our image ends up being as small as possible. And our application's Docker images, sorry, can be as small as possible. So in one case, we've saved on an average Docker image for one of our high-rank apps, which was 3.5 gigs, is now less than like 1.3 gigs. And then another part of the Docker kind of principle is that each layer is only rebuilt if its directive, sources, or parent layer have changed. So Docker, and otherwise Docker will just use a cached copy of whatever it needs along the way. So Docker is very efficient at caching, and it makes the builds much faster. So in shifting to a multi-stage build and ordering our directives really carefully, we took advantage of this caching behavior and made sure that the build could be as fast as possible. So in the single stage build, the early stages were more likely to produce changes, which then had to pull down everything and rebuild everything. In a multi-stage build, we only copy the gem file and gem file lock to the build stage and ensure that the bundle is rebuilt only if the gem file lock has changed. So what that means is that thanks to caching, most of our builds start at that little star right there, and then jump. Everything else is pulled over from a cache and a copy. So again, that's where we're saving the vast majority of our time. Thinking that doing one of these will do both. A little bonus here is that this has meant happier developers. These are my happy, smiling developers. So as folks know that have been working with Docker, one of the great benefits of it is that you can get close to a real mirror of production. But in our case, we feel like we've gotten about as close as you can get because we use containers for everything, including our Cantaloupe, which is our triple app server, Fedora, and Solar. It's the same exact containers that are being used in production. In addition, we have third-party Docker containers that we're running for things like S3, which are a direct mirror of S3. We're also doing that for elastic transcoding and some of the other natives. So when we stand up a stack, it looks and acts exactly like production. In addition, Michael wrote this little thing called DevStack that allows for a single devstack up command, and it brings up the entire environment. You can also bring up parts of the environment depending on what you're doing. And then this last bit shouldn't be passed over. You can run multiple environments by just setting an environment variable, so you don't have to throw away or back up all of your stuff if you're in the middle of something and need a clean environment in order to start debugging. I got all this. Hard things. There are always hard things, even when everything's a Docker container, right? So, one of the things we're working through is that we're still working through both Docker and AWS best practices. So the learning curve's been steep. We're learning a lot along the way. The documentation is rich, and there's a lot of it. But it keeps changing, too, in particular in AWS, right? Like, they're releasing new services. We're kind of constantly now keeping up with what we might be using in the near future. Some of the struggles we've had, as well, is how to keep deployed containers read-only using overlays. So some of this is kind of unlearning things we've known in the past about how to set up VMs and stuff like that. Some other stuff, we've run into some problems with trimming LVM volumes that Docker writes to, so the containers themselves would lock. And then ensuring that we're having a complete separation of containers and data. And that's like just a big principle, and it's something we're learning, something we haven't done right every time. This next part is sort of a sysadmin, DevOps, developers world. Now that we're walking in this world and developers have a lot more control over containers, something blows up in the middle of the night. It used to be obvious whose job it was. Now it's getting a little fuzzy. So we're still working through what that means and where the lines are drawn. And this last little bit speaks to the first thing as well, is that Docker containers aren't VMs, which is great, but they're not VMs. And we had a lot of years of experience running on bare metal and VMs, right? So we have to learn a whole new system. We also have to unlearn a lot of these old habits. I think I talked a little faster than I was this morning. So this last bit here is that we've written these things, they're largely around Northwestern's infrastructure, but we've made them all public. And if you want to, I mean, with our annual Terraform scripts, you can stand up the entire stack yourself if you wanted to and poke at it. It's probably a good starting point if anybody is interested in that. Our Docker images are available on Docker Hub. Some of them may be useful, including the core stack type of stuff. And DevStack, again, is largely NU-centric, but if anybody's interested in that type of model, it might be a good place to start and jump off on. And as always, we try, but don't always succeed, to write well-documented code that anybody can use. Let us know if anything is confusing on that. With that, I think I talked way faster than I meant to, but that means there's more time for questions, and I have Michael Klein on the phone, and I'll do my best Michael Klein impersonation. He can hear us if we talk into the microphone. Okay.
Where is it?
Hey, Michael, we got first questions coming in.
Okay. Hi, Michael.
Hi.
So one of the questions I had is, what are the consumers of your SQS? What's that look like?
Our queues are, we run our applications right now on Elastic Beanstalk through multi-container Docker. So the SQS consumers are the web app instance, which knows how to post messages directly into the queue. And then the worker nodes are just instances of the web app with a middleware mix-in provided by the AWS SDK gem that adds one or two HTTP endpoints to the web app that consume messages. That our code does not actually directly listen or pull messages from SQS. There is an AWS SQS daemon that runs on the worker nodes that pulls messages, posts them to the web app running on the same instance, and handles responses, the OK response, or knows how to deal with timeouts and time limits and failures, different types of HTTP errors. So the short answer is we are not directly consuming messages from SQS. We just have a web app that knows how to respond to posted messages from the daemon that is consuming messages from SQS.
Okay, that sounds a lot like Active Elastic Job. Are you using that, or is it something different?
We are using Active Elastic Job with some modification.
Cool.
I was just wondering, you mentioned that for Terraform, you have kind of an escape hatch if you want to jump out to something different, but it seems like you're pretty heavily invested in Amazon services. So how easy is that actual escape hatch given that investment?
It would be difficult. It would not be trivial or even easy. One of our hedges against needing it is that in addition to being heavily invested in AWS at our level, the university is as well. Like NUIT has an ongoing relationship with AWS, so we're strongly encouraged to use it as a service. But the benefit it gives us is that we have our infrastructure as code kind of arranged well enough that we know what we're using, which is not always the easiest thing to keep track of when you're setting up cloud resources. So even if we had to switch over to Google or Azure or some other cloud provider, it would be pretty easy for us to translate over the resources that have direct analogs in other cloud services like Docker container runners or virtual machine instances and other things like that. Finding replacements for the Elastic transcoder would be tricky, and CloudFront would be somewhat different, but at least it lets us identify, like, here are our easily portable bits, here are the parts that would require more effort and stuff. We don't have it, it's the next best thing to have it described in an abstract document, is having the code organized well enough to identify those pieces.
All right, thanks.
Sure, question in the back.
Hey, Michael, Francis.
Oh, hi.
We've talked about this, and one of the things that is missing in your awesome presentation is, and you know what I'm going to ask, is around how do you keep I mean, I know CloudWatch will keep track of who's logging in and who's doing everything, but how do you allow a way to know, I'm trying to get at how do you allow authentication and access control? I'm already thinking Active Directory, but can you elaborate, absent of, and I've looked at your Nullterra repo, but it's difficult to decipher how you go about saying, use a developer Francis accessed our authenticated and is allowed access to the following artifacts.
So when you say authentication, do you mean access to our infrastructure in order to deploy code and make changes to the infrastructure, or do you mean actual application level authentication against?
I mean the former.
Okay. Right now we don't do a lot of that. Everyone who has access has access to everything. We do have best practices in place where we use IAM users created with access keys, and there are audit trails of who has done what, but we don't currently have the need. We don't have a big enough group or specific enough roles within that group to narrow what people are allowed to do or prevented from doing by AWS access controls directly.
Last one. And so this is generic to AWS. You do not use anything from end use infrastructure? So the roles have nothing to do with.
Yes.
Okay.
The answer is half and half. We have IAM users. We only have one root user per environment, production, staging, and sandbox. And that root user never logs in. So we have everything is done through AWS IAM access keys, some of which are created from the console if we need to give a user access, but access to the console to create IAM users is handled through LDAP groups and SAML logins and stuff that happens at the NUIT level beyond. I can add people to those. I can change access within LDAP. I have access to the LDAP directory stuff. I have write access to the parts where I can take an NU net ID and turn them into an AWS user to log into the console. But I do not have any input or anything with how that was configured. That was all done by NUIT with Amazon and SAML and LDAP and things that I don't fully understand.
Thank you.
No multi-stage Docker questions? That's the exciting part, as far as I'm concerned.
Hi, Michael. I'm Steven.
Hi.
I have a question around storage.
Okay.
So there's a lot of stuff that we heard about how you're doing the transcoding, and I'm curious, are you storing all of the derivatives and all of your objects also in Amazon somewhere, or is that local, and how much are you actually dealing with?
David can answer the question of how much we're dealing with, because he deals with the metrics, but the derivatives are, we take our master images and videos and recordings, put them on S3, which is the only way to input to Elastic Transcoder. Elastic Transcoder also outputs to S3. So all of our derivatives are stored on Amazon S3. We use a CloudFront HTTP, caching HTTP distribution as our streaming server as well, because we only do HLS streaming. So everything, yes, all of our derivatives are stored on S3 and served up through CloudFront with some authentication in front of it. We also have a IIIF server reading from S3 for images. As far as our masters, those do initially go to S3. When we're finished ingesting them and creating derivatives, images go into Fedora. Fedora is using S3 for its binary data store. Audio and video files do not go into Fedora. They go straight to a preservation S3 bucket and then are removed from the ingest S3 bucket. And then we are currently working on on rules to move preservation stuff from primary S3 into Glacier. We don't have that implemented yet.
And we also do a local sync of those masters. So
Yes.
from S3, we sync back down to local storage.
We sync them back to our storage area network, which is also replicated to the Northwestern Chicago campus. And we have Postgres snapshots that get downloaded every night. We have Solar backups that get downloaded every night. Basically everything even stuff that is stored, everything except our derivatives, which can be recreated if necessary, even though it would be expensive and time consuming, gets snapshotted at least once a day. Solar gets snapshotted twice a day and replicated both into S3 and downloaded to our storage area network.
Do you know about how much your masters are?
Yeah, it's around 25 terabytes right now. We just deleted a bunch of derivatives, and that's sort of like the total number.
Okay, cool.
From a cost standpoint, it's been very cost effective.
Michael, how often do you end up rebuilding your base for your Docker images, and is that automated in any way?
Not enough. Every time something is deployed, it builds from the most recent cache, but about once a week or so, I have been manually deleting, just purging stuff from our Docker build host, which means that it pulls the base images again. And I do checks to see when those base images get updated and make sure that we keep them updated. But as far as keeping up with patches and other stuff like that, we don't have a regular automated mechanism for that yet.
And if I can do a follow-up question, do you deploy via tags or are you just deploying latest?
Yeah, we deploy via tags. We have, when I push, for example, app code to GitHub, the deploy/staging branch goes to staging, our production branch goes to production, and that happens by Jenkins recognizes the name of the branch that was pushed to, uses that to derive like nu-lib/donut : staging or : production would be the Docker image tag, and AWS also uses the environment specific tags to know which image to run in Elastic Container Service.
Awesome, thank you.
Sure.
I think we're at time too. I don't want to cut into the next presentation too much. Are there any other questions? Cool, thanks.
Thanks, everybody.